Hello YouTube, this is umills03. In the previous video, we took a look at while loops, and we said that basically there is a way that we can print a great deal of code without needing to write a great deal of code. And we studied the architecture of it, so what I have up on the screen right now is a very simple example of a while loop. And so what we can do is study this and spend a couple of minutes reviewing the while loop, although most of this lesson we're going to want to spend studying the architecture of the for loop. And so what we're going to see is that there's another type of loop that we can use that's pretty similar to a while loop, but the architecture is slightly different. And so we're going to just take a look at how to go back and forth between the two types of loops that are important to know as a computer programmer. So what we do is we create a string object called box, and we're familiar with string objects from lessons 5 and 6. We know how to operate on string objects, and we know some of the helpful methods that we can call, such as length and substring and index of and toUpperCase. And then what we do is we create an integer variable called counter. And the reason why you'd want to do something like that for a while loop is because the way that a while loop works is basically you write while, and then you have parentheses, and inside of the parentheses is going to be a boolean. You'd like that boolean to be true a number of times. You'd certainly like it to be true the first time it's checked. But eventually, in order to prevent an infinite loop, you'd like the counter to change value in such a way that eventually this boolean is no longer going to be true. And the way that you're going to cause that to happen is by saying by every time you go through the loop, you're going to increment the counter by 1. So if counter is 0 at the end of the loop, it's going to be increased to 1. If counter is 11 at the end of the loop, it's going to be increased to 12. And then you'd know that that was your last iteration through the loop. Because once counter gets to 12, 12 is not less than 12. And so we're going to go down to below the while loop. The while loop is going to be over. And then we can run any code that might be shown up here at the end. And so, of course, here what we would be expecting is 12 boxes and then an end. And so we can go ahead and verify that. So we're just going to compile it and run the main method of the hello world class. And indeed, you get the 6 boxes there, and then you get another 6 right here, and then you get the end. So hopefully that makes sense to you. Hopefully that's clear with what's going on. So this is a while loop, and there's 3 components of it. So there's the initialization of a counting variable, because normally with most while loops, you're going to see basically it keeps track of a variable, and then the variable is going to run up against some condition, some final value. And then of course, once the counting index gets to that final value, that would make the Boolean false, and then you'd be done. So basically, you have the initialization of a counting variable, you have a Boolean to check at the beginning of each iteration, and you have basically an incrementing to change the counting variable so that eventually the Boolean will no longer be true. This line of code is what prevents an infinite loop. If you think about what would happen without this line of code, you would just be looking at counter equals 0, and you would just be printing system.out.println of box, system.out.println of box, and 0 is always less than 12. So you would basically have an infinite loop. And so you need to increment counter so that it's eventually going to progress from 0 to 12. And 12 is not less than 12, but 0 is less than 12 forever. So the question is, do you want a finite loop that runs 12 times or an infinite loop that runs infinitely many times? So that's the working of a while loop. What we're going to do is we're going to take these components that you see here, and we're going to basically formulate a for loop instead. So we talk about the 3 pieces of the while loop, the 3 things you have to remember. Okay, so obviously you'd have to remember to do a task that's going to be repeated over and over again, and here it'll be printing box. But what are the 3 mechanical or fundamental or structural aspects of a while loop? So of course, remember we have the initialization, the Boolean, and then simply an increment. Those are basically the 3 words that you can remember: initialization, Boolean, and increment. With a for loop, we're just going to write those 3 things on the exact same line. So here's what we're going to do. We're going to say, I already declared counters, so I'm just going to call it something slightly different. So I'm just going to say counting index. So I'm going to say int counting index. All right. So for int counting index equals 0, counting index is less than 12, counting index plus equals 1. And then all that you say inside of the for loop is what code you're trying to repeat over and over again. So this is a for loop, and these 4 lines of code would have the exact same effect as these 6 lines of code. So what it does is it basically assembles the initialization, the Boolean, and the increment all into the same line, and they're all separated with semicolons. And then you don't have to worry about doing this extra line of code, because you run into trouble if you forget to do this increment of the counter variable here in the while loop. But in the for loop, it's built in. And so the for loop is literally incomplete without these three things. And so it's basically a little bit easier for you to remember to have these components if you don't have to basically write them separately. And that's why people sometimes tend to, for some reason, slightly prefer the for loop, is they just like the compact nature of basically taking care of all the things that you need to take care of in the exact same line. Whereas the while loop is a little bit more primitive, right? A little bit more just sort of like basic, right? Oh yeah, here's a boolean, right? And here's an increment, and here's an initialization. But for loop just says, let's just take care of all that stuff right at the same time. Let's get it over with. Let's figure out the mechanics, and just, it's a little bit more engineered in a sense, if you will. But now what we can do is we can go ahead and just, we're going to say system.out.println of end, just to show the working of these two loops, right? That you go ahead and run the loop, and then once you get to the end of the loop, you do proceed to the rest of the code. So you'd print end, and then it would go over to the for loop. And then once it finishes the for loop, once the counting index gets to 12, 12 is no longer less than 12. So then after those 12 iterations, after, the for loop runs with the 12 times, with the counting index taking the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, once you get to 12, you're not going to run it with counting index 12. It's going to check the boolean. It's going to say, nope, I'm not going to be able to run the iteration this time around, because now counting index is 12. And so what you do is, this second counting index gets to 12, you say, oh, this boolean's not true, and then I'm going to go print the end here. So anyway, we're about 7 minutes in, so let's go ahead and see the example here, and hopefully you can see how we put the pieces together. So what matches up with what? You have int counter equals 0. Now that goes right here after the word for. You say while counter is less than 12. Well, now that's sort of like in the middle of your for loop statement, in the middle of your for loop header, essentially. You used to say counter plus equals 1, usually at the end of the while loop body, but now it goes basically in the for loop header. What you have to remember is that this increment is still not going to take place until after the current iteration of the loop. So basically what that means is the first time that this iteration runs, it's going to say int counting equals 0. And that first time that it prints box is going to correspond to counting index equals 0. You don't do this increment until after the end of the current iteration that you're thinking about running. So it's going to say, is 0 less than 12? Yes. So run this iteration with counting index equals 0, and then increment it by 1. Okay, and then you would go ahead and check the boolean. Is 1 less than 12? If yes, then go ahead and run it with counting index 1, and then increment it. So the increment doesn't happen until after printing ln of t, right? Even though it technically seems like it comes higher up here. So that's just something you have to remember, right? It's just a slightly different arrangements of these terms between while and for loops. So anyway, let's go ahead and compile it and run it, and we should see the exact same output. So I'm just going to actually probably reduce it to a smaller number. So let's just say we want to have 4 boxes. So I'm just going to modify both of the loops just so that we're printing 4 boxes. It's a little bit less overwhelming on the eyes. We have box, 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 end, box, 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 end. So it's 2 slightly different ways of doing the exact same thing. And so we can have different examples, but hopefully you would be comfortable going back and forth between these 2 formulations. What we can do is we can also take a look at a for loop that will iterate through a particular string and print the uppercase letter, each of the letters uppercase on a new line. So what do I mean by that? Let's say string A equals Phoenix. Okay, and then what we're going to do is we're going to say for int w equals 0, w is less than a dot length, right? We'd want to iterate through the letters of Phoenix, so it would be helpful to know how long that string is exactly. And then w plus equals 1. So you can say w plus equals 1, or w plus plus, or w equals w plus 1. If you watched lesson 4 in its entirety, we said that those are the 3 ways to increment the value of a variable by 1 point. So then what you could do is you could basically go ahead and siphon off each of the letters in your string objects. And so what we did is in lesson 6, we talked about this method called substring. Okay, so what I'm going to do is I'm going to say string current letter equals a dot substring of w plus 1. So we said that the substring method, when it's called on a string object, if you feed two integers into it, remember it returns a substring where the first index position of the substring is going to be W, and the first index position that the substring will not include is W plus 1. So you can see there's only a difference of one character here. You're literally just going from W to W plus 1. So you would just be looking at that character at that index position, at that particular letter, okay? It's a substring of one character. It's just going from W, whatever W is, to W plus 1. So you'd be looking at, substring from 0 to 1 would be the first letter. Substring from 3 to 4 would be the fourth letter, okay? And so then what we could do is we can make it uppercase. And so we could go ahead and print the uppercase version of it on a new line. So what we're going to do is we're going to say system.out.println of current letter dot to uppercase. And this allows you to get a little bit more practice with the string methods that we talked about in lessons 5 and 6. But it just shows you, right, that this for loop is basically dependent on this variable called W. And so we're allowed to pick the values that W is going to take. And so what we say here is W is going to start at 0. W is going to run, the loop is going to run for all the values of W, starting at W equals 0, going up by 1 each time, and proceeding until the instant that W is no longer less than a dot length, right? Because the second that this Boolean is no longer true, it's going to stop evaluating this code. So hopefully you can predict what's going to happen, right? You run it with W equals 0, and it's going to say string current letter equals a dot substring of 0, 1. So it would assign current letter to this capital P here, and then it would just print the uppercase version of the capital P, which happens to just be that capital P. But for all the other letters, these are lowercase. So if you apply the to uppercase method, they're going to turn uppercase. And remember that with this print ln, where each of them is going to be printed on a new line. So now if you go ahead and compile it and run it, you get PHOENIX. So that's basically an example of using a for loop to iterate through the characters in a string object, okay? And you can just call the substring method and you can take a look there or something. Same thing, you could do a bunch of different things here so that you can see how this would be pretty valuable. What if you wanted to go down? What if you wanted to print the letters in reverse order? So a lot of our loops, we've been starting at index position 0, right? And going up to the end of a word or something like that. Or, up to a certain number, like W is less than 10. But what if we want to go in the reverse direction? So what you could do is you could be decrementing W. So you say, I want to start with larger values of W and work my way down. But then you wouldn't be starting at 0 and you wouldn't be checking to see if it's still less than the length. Actually, you want to reverse these. So what you'd actually be doing is you want to start at a.length minus 1. And then what you're gonna do is you're gonna go all the way down to 0 and you're actually going to include it. And the reason why you do that is you have to think about the way that the substring method works and the way that index positions work. If the string A has a length of a dot length, that means that the biggest valid index position is a dot length minus 1, right? You think about a string with 7 letters in it. The last valid index position is 6 because we said that in Java, we start index positions at 0. So what this would be doing is it would basically form a substring that begins at the last letter. And then what you would do is if you call that last letter, and then what's a dot length minus 1 plus 1. So it would just be a dot length. So if you want the last letter, I don't know how much of a point I should make out of this, but basically if you have for a string T, you would say T dot substring of T dot length minus 1 and T dot substring of T dot length minus 1 up to T, both return the last letter in T. So hopefully that's clear to you, right? We were talking about how you could either use the substring method that just accepts one index position, right? And then you would just start at that last letter, right? And then go to the rest of the string, which, at that point just includes that last letter. Or if you want to be formal about it, you can start at the last letter and say, I only want one letter, right? So you would just go from the last letter up to literally the tail end of the string. So either one gives you the last letter, but that's what you're going to start with this time, right? So you're actually going to start with the X, okay? And you would print the capital X, and then you would iterate through. So you're actually going to work your way down. So W is going to start at 6, And then it's going to say, okay, 6 greater than or equal to 0? Yeah, so I can run this method with w equals 6. And then it's going to run it with w equals 5 because you decreased it by 1. So is 5 greater than or equal to 0? Yeah, it is. So now I can go ahead and run this method with w equals 5. And you can see it's just going to pluck out the letters of Phoenix, but it's going to do it in reverse order. So now if you go ahead and run it, you can see Phoenix is capitalized and in reverse order. So hopefully you can understand how that works. We can also go ahead and basically have the variable for a while loop or a for loop. This applies to both loops, but it doesn't have to be an int. It could be a double, okay? So you could go ahead and say double E equals 4.2, and then you could say something, you could do something weird, right? Like while E is less than 7.3, you could say system.out.println of E, and E plus equals, 2.5. But the whole point is that, you don't have to have ints in your counting indices. So what would this do? It would print 4.2, and then it would add 2.5 to that. So then you're talking about 6.7. And 6.7 is going to be the last value of E that's less than 7.3, because if you're going up by 2.5 each time, the next value of E would be 9.2, which is no longer less than 7.3. So we should expect to print those two values. And then if you want to formulate this as a for loop instead, it would be very similar. You would say for double f, let's call it f this time, f equals 4.2, f is less than 7.3, f plus equals 2.5, or f equals f plus 2.5, right? Same thing, either way. And then all you put in here is system.out.println of f. And so these two formulations work the exact same way, and hopefully you're able to mix and match. Hopefully you're basically able to line these pieces up with one another and see how we go from one formulation to the next, okay? You could also, you could do adding or subtracting. You could also multiply. So what if you want to print the powers of 2? So what you could do is you could say something like int power equals 1, right? And then you could go ahead and start it. So you could say for int power equals 0, right? And then you could say, power is less than 5 or something like that. And then you could say, what if you want to go up by 2 powers of 2 every time? Okay, so what this would do is you could say system.out.println. Let's just print the value of power. Okay, so the whole point of what I'm trying to say here is that you can go up by whatever you want. So you don't have to go up by 1, you don't have to go down by 1. We just saw in the previous example, we were going up by 2.5. So it doesn't have to be an int, right? And so you can go ahead and, just decide whatever it is that you want to do here. And so now you would get the 0, 2, 4, because we're looking at power equals 0. And so do we say 0 is less than 5? Yes, so go ahead and print 0 and then increment it by 2. Is 2 less than 5? Yes, go ahead and print 2 and then increment it by 2. Is 4 less than 5? Yes, go ahead and print 4 and then increment it by 2. Is 6 less than 5? No, so that's why we stopped there. And then obviously if you wanted to go the other direction, what you would do is you would say int p equals 0, and then you would say while p is less than 5, and then you write what you're trying to print and then the increment. So you say system.out.println of p, and then p plus equals 2, and then now if you go ahead and compile it and run it, and then you could see the main method and you get the exact same code. So a for loop is basically just another formulation. It's another way of basically doing the same thing that a while loop does. The only difference is that with a while loop, you're usually talking about initializing a counting variable before the while loop even starts. And then in the while loop header, you just have the boolean that you're checking at the top of each iteration. And then somewhere in the body of the while loop, you'll need to basically probably update a variable in such a way that eventually the variable is going to run up against a condition where the boolean that the while loop is checking at the top of each iteration is eventually no longer going to be true. The same exact kind of methodology happens with a for loop, but it just puts all the pieces into the same place. With a while loop, we did the initialization, and then we see the boolean, and then we see the increment or decrement. With the for loop, we sort of see all three of those things at the same time. We see the initialization, the boolean, and the decrement or an increment all in the same line. The only thing you have to remember is that this increment is not going to happen until after the current iteration of the for loop. So it's going to print system.out.println of 0, right, before it prints system.out.println of 2. So hopefully you're comfortable going back and forth between these two formulations, and you can decide for yourself which of the two loops is your favorite, and we're going to be using them a lot going forward. So from UMills03, thanks for watching, and please subscribe.